I found this old book in my basement. I used to be sort of a Haskell programmer, wrote some programs in university. Well, it's a short read. In comparison, if we look at the C++ in production compendium, this is what it would look like. And this talk is about some lesser known facts about Rust and why it's used by companies, and not necessarily only multi-billion-dollar companies. So the alternative title for this talk is Real-World Rust. How is Rust used in the real world? I'm curious, who has written a single line of Rust in this room? Like literally 80%? Okay, keep your hands up if you wrote Rust code before 2020. Okay, still quite a lot of people. Before 2019. Less, 18. 17. A few people, 16. Okay, anyone still? It's like the Titanic when they go around and the boat has sunken and they look for survivors. It's okay. So, I'm Matthias. I have a consultancy called Code. I'm an open source maintainer, and I also run the Rust in Production podcast. Who has heard of that one before? Okay, yeah. Roughly the amount of people that wrote Rust in 2016, apparently. So I turned 40 2 days ago, so now I can finally use that slide. And it's been quite a few years since I started using Rust. I started in 2015, and then in 2019, I had my first production service at Trivago, and then I became a Rust consultant in 2021, and in 2025, we're here today. So Rust is not a new language by any definition of the word, but for programming languages, it might still be a relatively young language. But in those 10 years, in that last decade, a lot went really right for Rust. Everything went up and to the right. For example, this is the number of crates on crates.io. Crates.io is like the package manager of Rust. It's the package registry. And you can see that there's some sort of exponential growth. Everyone that started before 2020, you basically saw nothing yet, and then it kind of started. Or that's the number of Rust conferences worldwide. Yes, I did some research on that. It was painful. And you see, it went up and to the right. Not exactly, but we also know what happened here, right? So you could say that there's an upwards trend, at least. Or let's look at the number of book releases for Rust. And again, there's some sort of trend. I don't know what happened in 2025. We need to write more books. I would say Rust is doing fine. But then again, let's address the elephant in the room. What you might be thinking is, well, this is yet another Rust is great talk in disguise. And let's face it, there's a risk. You took the risk today. And someone might stand here and tell you all the good things about Rust and everything being perfect. I don't want to do that talk today. I just wanted to honestly talk to you about it, because I think you should know why Rust is so popular and why companies use it in the first place. The truth is, though, I'm a salesman. In actuality, if Rust is successful, I'm successful, because I run a consultancy. I help people go from prototype to production. And that's the problem, because I'm biased. Now, I thought about this for a long time. On one side, I want to present the truth to you. On the other side, it's very hard for me to do so. And I collected a few quotes from companies I work with. I wanted to show you, well, why they use it, why they don't use it, what the risks are, and essentially why you should consider using Rust, or perhaps you considered using it in production already, or maybe you do. But if you need to convince your manager, maybe they should watch that talk later on. I know, managers don't really watch tech talks, okay? So, does anyone know William Bernbach? Has anyone heard that name? He said the most powerful element in advertising is the truth. And I really like that quote. You might not know the person, but maybe you know the reason why this person is famous. Because they did these really cool advertisements for VW back in the day, back in the 70s, I guess. So a lot of people complained about VW. And every company literally just looked at their product and said, it's the best thing you can buy. It's the best ever since sliced bread. But what this company did for VW was to listen and to understand and to say, well, it might not be perfect, but maybe you just look at it the wrong way. And they came up with quotes. And this one is, for example, they said it couldn't be done, it couldn't. And I think that's kind of nice because, well, if you're that tall, yeah, you won't fit into a VW Beetle, but if you're just a little less tall, you will fit in. And that is kind of what is down here. I kind of like that because that's the truth, there's no lie to it, and then you can still make up your mind and you can decide if it's the right thing for you. Or this one. A lot of people said VW cars are ugly. And they turned it around and said, ugly, yeah, it's true, ugly, but ugly is only skin deep. And I will read a section from the bottom here. They say, it may not be much to look at, but beneath that humble exterior beats an air-cooled engine. After a while, you like it so much about the VW, you even get to like what it looks like. And that's kind of nice, because the same is sort of true for Rust. A lot of people say Rust is ugly. And I don't really disagree. It has its origins in OCaml, and yeah, you might say the same thing. But beneath the surface, there's this beautiful engine, and after a while, the ugliness just fades away. I personally believe that Rust is not ugly anymore. But yeah, that's just survivorship bias, I guess, or Stockholm syndrome. Now, the agency was called Doyle, Dane, and Bernbach, and they had this guiding principle, and I really like that guiding principle. That's from another founder. And he said, we wanted to set up an agency with principles we could believe in, to be perfectly honest with the client, to give him, it dates the quote a bit, but to give him the work we think he should have, provided it fits their goal. And I kind of like it. So it's the perfectly honest truth. And coming back to this, the most powerful element in advertising is the truth. And just to add another quote on top of that, Oscar Wilde once said, the truth is rarely pure and never simple. I will say today, you get the impure, complex truth about Rust. I guess that's fair. I said everything went up and to the right. Is that correct, everything? Well, there are a few things in Rust's history that were not so great. First, in 2020, Mozilla, who famously sponsored Rust, started to let go of a lot of the Rust core team. And then they found work in other places like AWS or so. And that was definitely a downer, because that meant that Rust's future was not really guaranteed. Or that the Rust project had a burnout problem when the Rust 2018 edition, and then also later in the recent editions, was really under a lot of pressure. A lot of people burned out. And there are people in the community, maintainers, which were struggling during that time, and some people left. And this is the reality of open source. This is not specific to Rust, but in Rust, it's very much, I guess, a bit of a problem here. I guess that also belongs to the story where the Rust Foundation decided that you can no longer use, well, the trademark in any publication or any talk. I couldn't do that if I had to. Well, fortunately, they rolled it back, so now I can show you the Rust logo again, and I can show the little Ferris. But the Rust Foundation and the Rust users, they have a bit of a troubled relationship at times, or at least they had. Is Rust just a hype? I listed all the hypes. AI, you make up your own definition, but there were a few hypes recently. I guess we can all agree that the metaverse, okay, is a bit of a touchy subject sometimes. The question is Rust also just a hype? Is it really necessary to have Rust in our infrastructure? Or does it even have a reason for existence? The question is, why Rust? Why do companies really use it? What is the reason behind that? A lot of people would say safety is the main reason. If you talk to someone who hasn't spent a lot of time with Rust, they will immediately say, oh yeah, it's so much safer. But what does safety really mean? In practice, do you have a problem with your code base, safety-wise? Well, I don't know. If you're a web developer, you have a lot of problems, but maybe other languages also are reasonably safe. Is safety really a good argument for Rust? These languages, by some weird definition of the word, are also safe. They do weird tricks and shenanigans to get there, but by all means and purposes, you can use them in production and you don't shoot yourself in the foot. So why would you even choose Rust if you had these? Why wouldn't you go with Go or with Python? Well, the problem is these are not necessarily systems-level languages. You can't do everything that you can do with C and C++. And that is the problem, because C and C++ are not necessarily memory safe. And note that I say memory safe here, which is a much smaller subset of safety. Rust still has safety issues, but it prevents you from memory safety issues. These languages, C and C++, do not. And that's a problem, because this way you cannot replace a C++ code base with, say, Python in production very easily in all environments. If you build a fighter jet and you have a navigation system that is written in C++, well, you can't easily use Java if it triggers a garbage collector in the middle of your mission. So that's a bit of a problem in the real life. I don't know where I was going with this example here. Rust is, I would say, the only or one of the few low-level languages which are safe. And I'm standing here in front of you saying that all the C and C++ developers are in fact wrong about this. And they are wrong because of this, for example. Who can spot it? Which program is it? Shout it out. First one gets a sticker. Cool. Yeah, you get a sticker. Oh, wow. Nice. Yeah, that was segfault in curl. It was a week ago. And the author, the maintainer of curl, Daniel Stenberg, said, it sometimes amazes me how many bugs that can still be found. And he says, one bug fix every third hour. This is a code base that he has been working on for more than a decade. One bug fix every 3 hours. That's a C code base. Or this one, Redis shell. Anyone heard of that one? That was not too long ago. There was a remote code execution in the Lua interpreter in Redis, and it was enabled by default. And a lot of people, I posted that on LinkedIn, and a lot of people replied. And I blurred them out to protect the innocent, but they say things like, this is the reason why OpenBox unit automated tests exist, right? So thinking there is a magic ball like Rust or others which will resolve the issues of remaining bugs without the painful and long job of writing is no nonsense, I don't know, and a lie. So unit tests solve this. Okay, strong statement. Or this one, that's a false dichotomy. No C nor Rust developer should be writing safety critical code like this without using a model checker? Well, a model checker would have prevented that issue in Redis, apparently. Or this one. I think the conclusion is wrong. Mistakes happen, period. Be it C, Lua, or Rust. That's it. There is no holy grail. Well, no one said there's a holy grail, and mistakes do happen, but that doesn't mean that we should not prevent all of these mistakes that we can prevent automatically. Here, this one. By the same logic, even Rust can be vulnerable. Rust is software that was expertly written by some of the best engineers in the world. Mistakes can happen too. The difference is, if you fix a problem in Rust, you will fix all the code bases written in Rust automatically if you recompile your application. It's a bug in the standard library if there's a memory safety issue. That's the difference. If you fix a bug in Redis, you fix a bug in Redis. That's it. Not any other software. Or this one. Let's embed arbitrary code execution to Rust program and see how secure it will be. It will be more secure because Lua runs inside a virtual machine, and this particular bug was a use after free, a null pointer. That means it would not have compiled in Rust. That's the difference. It did compile, it did run in C. Yeah, I won't quote this one. I guess you can read it yourself. I don't even know what to make of this. But basically they say, these are not expert level engineers who wrote Redis. So they work on Redis for a decade. Apparently they are not experts. And there's plenty of Redis instances that still have security issues. Well, that's true, but like, why not prevent the ones that we can prevent? The list goes on and on and on. What those people say is basically, bad programmers wrote that code. Unit testing would solve this. Model checking would solve this. Mistakes can happen. Fixing this issue won't fix all of our problems. You get the drift, right? Rust calls unsafe C, so Rust must also be unsafe. People come up with these answers which are simple but wrong. And they keep repeating the same mantras over and over again. And this is why we can't move on as an industry. When I post something on LinkedIn, people always say, I'm some sort of Rust evangelist. But in reality, what happens, the C and C++ developers, they pull out their pitchforks and they go on a manhunt. So to me, it feels so backwards, really, because we should have that conversation about issues that we can prevent. And no, C++ 26 will not solve this, and perhaps not 29, and maybe not even 32. Because underneath the C++ implementation, or inside of that implementation, there are still issues, and you can still sidetrack the new safety regulations inside C++. Ubuntu is oxidizing Rust. They replaced the core utils. And there's a nice quote from someone who said, GNU core utils has basically never had any major security vulnerabilities in its entire existence. So why do they rewrite it? And then I looked it up, and of course, there was one just a few weeks ago. That was in Sort, a program that is used billions of times a day. And yet, there was a security issue in the GNU core utils. So that argument is obviously wrong. Or why rewrite perfectly good software? Coming back to Daniel Stenberg, he said, more than half of curl source code has been changed within the last 4 years. And he said 1,101 lines from before year 2000 still remain untouched. The myth is that you never change C code once it runs, once it compiles, once it is done. And in reality, people like this, who are experts, they say, we rewrite it all the time. That means you introduce new bugs, you make new mistakes. But people say, it's 100% orchestrated, it's a conspiracy, it's a cult. And yet, you look at people like John Seeger from Canonical, who said, well, we're shipping the most resilient and trustworthy software that we can because millions of Ubuntu users trust us with their data and every day. So it's not really a conspiracy. The people from Git use Rust, from Linux use Rust. They made up their mind, they decided themselves that they want to use it. No one forced them to. So there's more to it then. Is it for performance reasons? Well, performance is a big problem because a lot of languages are really fast. If you look at this chart here, Rust is really fast, but so is, for example, Haskell, so relatively speaking. So performance is not really a big issue. And yet, you look at Cloudflare rewriting their router, their proxy, from Nginx and Lua, which is written in C and Lua, of course, to Pingora, which is written in Rust. And they can save 50, 60% of CPU and memory just by doing the rewrite, because people start to be more ambitious. They start to use multiple threads. They start to use SIMD. Suddenly, things are safe. Suddenly, you can refactor and experiment. And this is how you get the performance gains. People always talk about the performance, but Stefan Baumgartner, a friend of mine, he said, look for the stability gains. This is also a big factor of why people use Rust. People build safe and reliable systems. This was Nicolas Matsiakis says, who's one of the Rust core maintainers. And I think that is true. People are more confident about their code. For example, this is a Google survey. On the left side, you see people are much more confident in Rust code that they ship at Google. You can see it. Robustness, is that a factor? I would say so. Let's look at an example. Here's some Python code, okay? We want to count words. So first thing we do is we open the file, we read the content, we read the words, and then we calculate the length, right? That's the book example. Okay, but we forgot to close the file. No big deal. Let's close the file. Well, actually, what happens if it crashes before we close the file? Well, there's this syntax here, which kind of guides us from this. We use the with syntax here. Well, what if there was an exception? What if the file was not found? Well, the program itself doesn't really tell you that much. So you need to have that exception handler. You kind of have to know about it, because that can crash at runtime. But there are multiple different exceptions. What if the path is a directory? What if you cannot decode the Unicode string? What if you don't have permissions? And by the way, what does split even split on? What is the encoding of the file? These are all questions that you have to solve. This is the equivalent Rust program. People say Rust is complicated, but the reality is systems are complicated. This will automatically return an error. That means you will know when this operation fails, and you will have to handle the error, otherwise you can't get to the value. And yeah, there's a split white space and a count. So split white space does what you think it does. It splits on white space, so spaces and tabs and so on. Rust shifts the complexity to the left, to development. And Python wants you to fix it in prod, so to say. I found that Rust codebases scale really well, whereas Python codebases sometimes fail between 10 and 100,000 lines of code. Rust is a day 2 language. That's the problem, because you have to see it to believe it. You have to run it in production to see the benefits. In Go, for example, you get a lot of benefits on day 1. Everything feels nice. You're in the happy path. But on day 2, that's a bit of a problem. So I'm a salesman. That means let's look at some client quotes. Here's a company here in Germany called AP Sensing. They built this server, which does predictive maintenance for infrastructure, for example, for train tracks. And they use Rust. And I asked Jonathan, why do you use Rust? And he said, we use Rust for fast, memory-safe ML inference at the edge with easy Python integration. I highlighted the integration part because that's a common theme. People want to integrate it with other languages, and Rust allows you to do that because it doesn't have a runtime. Or this one. This is for the e-ticket system, which is used by a lot of train stations and train providers. For example, Hamburg uses it as well. And I asked Fabian from MCon, why do you use Rust? He said, we use Rust to create a modern memory-safe software library for interaction between different hardware components, which can be used with various high-level languages, such as Java and C#, and runs easily on many different devices. Here you have it again, interoperability, different hardware, different software. You need to make it work on, for example, an Android device, on an iOS device. Well, it's a library, you can just integrate it. Or Rory, one of my favorite use cases for Rust, because they built a chatbot for students in Africa. And what they do is they use Rust on the back end to provide students with questions and evaluate the answers. And I like what Dylan said about their Rust usage. He said, we don't use Rust because it's cool. We use it because it is the most suited for the unique resource constraints of an African context, namely the resource constraints of devices, cloud costs, developer time, energy use, and climate impact. Rust is really energy efficient, and they build this software with a really small team of a few people. And they handle thousands of students, and this is really cool. Rust allows them to do that. They don't use it because it's just cool. Or here's another example. Here's a client of mine who reads data from eBay, 80 gigabyte CSV files, converts them and writes them to Google Merchant Center. And yeah, I asked Chris, why did you use Rust for that? And he said, well, Rust was just 20 times faster than Python for batch processing, while using fewer resources. This resulted in significant infrastructure cost savings. So you see it again, cost savings, reliability, those are the real drivers, not necessarily safety. Here's another one. Veo does sports tracking. They have these cameras, they put them on fields, and then they create highlights automatically. That runs on device. Yeah, we use Rust because it allows us to shift from runtime errors to compile time checks, says Martin Berger from Veo. I really like that because it shows you, well, this is the real reason why people use Rust. They want to shift complexity to the left. And Rust is perhaps the only language in that list that integrates with all of these different components. I won't read it out right now. You can watch it later. I think Rust is great for foundational software. Rust is amazing for software that underpins other software. That's what foundational software is about. And what that software is for you, well, you decide. But it's a thing that needs to work 100% of the time. So coming back to this initial slide, I believe that we can write a book which is like this, but maybe a bit longer and has more content. I think Rust is pragmatic Haskell, and it allows you to run high-level code on bare metal. All of these companies were guests in our podcasts, and not all of these companies are huge companies. So just remember that. If you want, you can listen to our podcasts. We have some sticker here. And I think with that, we are crossing the chasm of early adoption to early majority. And here's some tips on how you can get started. And that's all I have for you today. Thank you very much.